Teaching mixture problems with the Coin Lab activity. The Coin Lab activity helps students understand how to set up mixture problems, which are common applications throughout algebra. The situation in the Coin Lab activity is specific to coin word problems, but the organization and methods of solution can be generalized to other mixture applications. The Coin Lab activity uses plastic pretend coins. You can make paper coins if you didn't have plastic coins, but you'd probably need a new set of paper coins each time you do the activity. Why is this a good activity to help students learn how to solve mixture problems? The Coin Lab activity starts with a familiar everyday situation, finding the value of a handful of coins. Most students rely on a strategy they've used in real life to find the total value. In this activity, students are asked to describe their strategy in words, so they reflect on how they apply mathematics in real life. And the activity reinforces the distinction between the number and the value of each type of coin, two quantities that are frequently confused by students solving coin mixture problems from rote memory. So instead of relying on memory, students have a concrete model they can visualize as they do algebra coin problems. The model leads them to a logical, organized strategy that they can use in other types of mixture problems they will encounter in algebra. So what is this Coin Lab activity? You're given a handful of coins and have to calculate the total value. Let's see what this looks like. This is how a handful of coins might look when dumped onto a desk. In order to calculate the total value, most people rearrange the coins so that they're grouped by type of coin. Some people take a different approach. They may group the coins into $1 piles, but we will focus here on the solution method of grouping by type of coins. We'll tidy up the piles here to make it easier to count the number of each type of coin. Now we'll do the math to calculate the values. We have 3 quarters worth 25 cents for a total of 75 cents. We multiply the number of quarters by the value of each quarter to get the total value of the quarters. Similarly, we calculate the total value of the dimes and the pennies. I always have to warn my students to be careful with the decimal numbers for the values of dimes versus pennies, 0.10 versus 0.01. Finally, we add up the total value of each type of coin to get the total value of all the coins, $1.39. In my class, many of my students will show work something like we saw on the last slide. Then I introduce them to a table like the one shown here to organize the information. We label the columns type of coin, number, value, and total value. The handful of coins we counted had quarters, dimes, and pennies, so we write the coin names in the type of coin column. And then we fill in the number of each type of coin, its value, and the total value of each type of coin. Finally, the students tell me to add up the total value column to get the total value of all the coins. After filling in the table with the specific numbers, I like to ease my students toward examples that will require algebra to solve. Using the same numbers we've been working with, 3 quarters, 6 dimes, and 4 pennies, I use the variable q for the number of quarters. Then with the help of my students, I'll write 2q for the number of dimes and q plus 1 for the number of pennies. For each type of coin, we multiply the number by the value to get the total value. We add up the expressions in the last column to get the total value of all the coins. This gives us the equation shown at the bottom of the slide that we will solve for q. Here are some suggestions for using the Coin Lab activity with your students. I do the Coin Lab activity in class to start the section on mixture problems. To prepare for this activity, I bag up handfuls of pretend coins into Ziploc baggies. There's no need for all the baggies to have the same number of coins because the lesson here is the method of solution, not a specific numerical answer. I like to have my students work in small groups of 2 or 3. I give each group a bag of coins and tell them to calculate how much money is in their bag. I ask them to turn in one paper per group where they describe in words the methods they use to calculate the total value of the coins and show all their calculations. While they're working, I walk around the room and glance at their papers. I often have to remind students to be very specific in describing their methods. As I walk around, I also take a few notes so that I can create some examples using my students' names and their coins. When it looks like all the groups have finished, I ask some of them to write their methods of solution on the board and explain them to the class. Then they fill in the table to organize their work. So this is how I might make up an example with a student's name and coins. Suppose I see that Lily has 5 quarters and 17 nickels. While the class is still working, I write this problem on the board. After the student groups have shared their methods of calculating the value of their coins in their baggies with the class, we'll work through this Lily example together. The first step is to set up the table and fill in the types of coins, quarters and nickels, and their value. Then we introduce the variable. Do we want to use N for the number of nickels or Q for the number of quarters? This is always a tough decision for my students. Usually I go back to the sentence, she has 12 more nickels than quarters, and choose some specific numbers, temporarily ignoring the total value. What if Lily has, say, 15 nickels? Then 15 plus 12 means she has 27 quarters. Does she have 12 more nickels than quarters? No, Lily has more quarters. So instead, we let Q represent the number of quarters, and Q plus 12 gives the number of nickels. Once we have filled in the number column, we multiply across each row to get the total value of the quarters and the nickels. Finally, we solve the equation shown under the table now, and I'll ask the class to solve it. To check the answers, we make sure the total value comes out to be $2.10, and Lily verifies that she did indeed have 5 quarters and 17 nickels. Where can you find plastic pretend money? There are sets of plastic coins at teacher supply stores. Some children's games and toys use coins. If you have children at home, you might borrow from their toy box, especially the first time you use the Coin Lab activity. If you want to print your own paper coins, you can find free clip art images of coins online. The best online activity I've seen with virtual coins is on the National Council of Teachers of Mathematics website. It's the NCTM's Illuminations Coin Box activity. This is the first view of the Coin Box activity. Choose Count to get an activity similar to our Coin Lab. You will see a bunch of different types of coins, and you'll be asked to calculate the total value. This activity even gives you an option to show the value of each coin right on the coin's image, which can be especially helpful for our international students who may not be familiar with U.S. coins. Here's what the coin box activity looks like. A bunch of coins is scattered around the workspace. There's even a realistic clinking sound as they appear. You have to calculate the total value of all the coins. What I like about this activity is that you can drag the coins around the workspace wherever you want. I like to group the coins of each type together. Then I calculate the total value and check my answer. I hope you want to try the Coin Lab activity with your students. This is Mary Ann. Goodbye.